Press the bell icon on the YouTube app and never miss another update.
So in the last class, we have discussed about that Ohm's law. Now we will take class 5th of 10th electric current. So we will take some key points regarding Ohm's law. Number one, from Ohm's law, we have V is equal to IR, that is potential difference is equal to current into potential difference is equal to current into resistance. Therefore, this potential difference, right, is defined as the product of current and resistance. Sometimes this the term right hand side is also called as IR product. Right. Now, second one, again from the Ohm's law, that current I is equal to V by R. Suppose if we know potential difference between the ends of the conductor and or resistance of the conductor, we can calculate the current flowing through it. Now the third important thing is when V is constant, when V is constant, that is a potential difference remains constant, then the current is inversely proportional to resistance of the conductor, right? So we say that I is proportional to 1 by R, or I is inversely proportional to R. Current is inversely proportional to resistance. That means when V is constant, if we go on increasing the resistance of the conductor, the current in the conductor decreases, right? Generally, in order to vary current, to increase or decrease current in a circuit, generally we cannot alter potential difference. For given battery, potential difference remains constant, but the current value can be altered by altering resistance of the conductor used, right? If we increase the resistance of the conductor, current decreases, or if we decrease the resistance of the conductor, the current increases, and this is the importance of Ohm's law. Suppose if we plot a graph of, right, I versus V, if we plot a graph of current against potential difference or voltage by taking current along y-axis and potential difference along x-axis. Here for voltage 0, current is 0, so we will obtain a straight line curve like this, right? So this indicates the current is directly proportional to V, potential difference, right? So the curve of current against potential difference graph applied to a conductor is a straight line passing through the origin, indicating I is directly proportional to V. Now, let us take up a few numerical problems, right, on resistance, right? And before going to that, we will define, right, resistance of a conductor, right? So far we have learned what is potential difference, what is electric current. Just we have mentioned only resistance, right? According to Ohm's law, V by I is equal to constant, and that constant is called electrical resistance of a conductor. Now we will take right, resistance denoted by the standard symbol R, right? Now, resistance of a conductor is the opposition offered by the conductor for the flow of electric current through it. So, resistance of a conductor is the opposition or obstruction offered by, right, the conductor for the flow of electric current through it. So, meaning of, right, that electrical resistance. Resistance of a conductor is the opposition or obstruction offered by the conductor for the flow of electric current through it, right? Now, what is the cause or reason for electric resistance of a conductor, or why a conductor offers, right, opposition for the flow of electric current, right? We know that a metallic conductor, right, consists of, right, free electrons and vibrating ions or atoms. Atoms means, or ion difference is when one or more electron is removed from an atom, it is called as ion. We can call it as ion or atom. More correctly, it is an ion, or we can call it as atom. So when potential difference is applied, right, when a potential difference V is applied, now the free electron starts moving from lower potential to higher potential, right? When it starts moving, it collides with one electron, right? It collides with an electron, right? I mean, ion. Then this ion, the direction of electron will change. Then it moves and collides with another ion. Now again here it travels and collides with another ion, right, and finally reaches the other end, right, the electron. So the electron, while moving from one end of the conductor to the other end of the conductor, it encounters with a series of collisions with ions or atoms of the conductor. Therefore, the path of electron is obstructed by the collision of electrons with the atoms, right? Therefore, the time taken by the electron to move from one end of the conductor to the other end of the conductor increases, right? Now, as we know that I is equal to Q by T, as T increases, current decreases, right? In other words, there is an obstruction or opposition offered by the conductor for the flow of current through it, right? So, the resistance or opposition is due to the collision of free electrons with atom. That is the reason why a conductor offers opposition, right? More the opposition, more the resistance. Less the opposition, less is the resistance, right? Now, let us define resistance of a conductor. Definition of resistance, right? Now, so far what we have discussed, it is the meaning of the electrical resistance. These statements do not give any right method of measuring what is the quantity of resistance offered by the conductor, right? Now, from Ohm's law, we have V is equal to IR, or R is equal to V by I. Right. Here, what is R? Electrical resistance. V, potential difference. I is current. Now, this can be written as resistance is equal to potential difference by current. Therefore, resistance of a conductor is defined as the ratio of potential difference between the ends of the conductor to the current flowing through the conductor, right? Or this SI unit of resistance. SI unit of resistance is O. Right? It is denoted by the symbol like that, right? This is the Greek alphabet. It is called capital omega, right? Again, just like in English alphabets, in Greek alphabets there are capital letters and small letters, right? This is the capital letter omega of Greek alphabet, but here it is called as O, right? Now again, by definition, right, we have R is equal to V by I. So unit of R, that is O, is equal to unit of potential difference, that is volt, by unit of current, that is ampere, right? That means, right, so ohm is equal to volt per ampere. So the actual unit of resistance is volt per ampere, and this volt per ampere is called as right ohm. Right. Now, let us define The SI unit of resistance or ohm. Right. Again, we have R is equal to V by I when V is equal to 1 volt, that is applied potential difference across a conductor is 1 volt, and the current obtained I is equal to 1 ampere, right? Then write R is equal to 1 volt by 1 ampere is equal to 1 ohm is equal to 1 volt per ampere. That means 1 ohm is equal to 1 volt per ampere. Therefore, the resistance of a conductor is said to be 1 ohm if a potential difference of 1 volt, right, between the ends of the conductor produces a current of 1 ampere. In other words, if a potential difference of 1 volt applied across the ends of a conductor, right, produces a current of 1 ampere in it, then the resistance of the conductor is equal to 1 ohm, right? Now we will take numerical problems. Again, I will read it out here. Right. Problem number 1. A potential difference between two ends of a wire carrying 2 ampere current is 0.1 volt. Calculate resistance between these points. Right. Here we have given potential difference between ends of a conductor. Now the given data, now potential difference between ends of the conductor V is equal to 0.1 volt. Now what is the current flowing through the conductor? The current flowing through the conductor I is equal to, right, it is 2 ampere. What we need to calculate, that is resistance of the conductor or between the two ends of the conductor. Now the resistance R is equal to what? Now from Ohm's law we have V is equal to IR, or R is equal to V by I, or R is equal to, what is the value of I? 0.1, right? The current is 2, right? It is 0.1 volt by 0.2 ampere. So R is equal to 0.1 by 2, that means 0.05 volt per ampere is ohm. Therefore, the resistance between the 2 points of the conductor R is equal to 0.05 ohm. Now, we take second problem. A simple electrical circuit has a battery of 24 volt and a resistor of 60 ohm, what will be the current in the circuit, right? Here once again, if you take given data, here we have given a battery of, right, potential 24 volt, right? What is the function of a battery? To provide potential difference between any 2 points in a circuit. Therefore, the given potential difference V is equal to 24 volt, and the resistance of resistance R is equal to, it is 60 ohm. Now what we need to calculate is current. Current I is equal to what? Again, from Ohm's law, we have V is equal to IR, or I is equal to V by R. Now V is given, R is given, we need to calculate I. So I is equal to, what is the value of V? 24 volt by resistance is, right, 60 ohm. Therefore, I is equal to 24 by 60 comes out to be 0.4 ampere. So, the current flowing through the circuit is 0.4 ampere. Right. Now, so far, just we have mentioned in the previous classes, ammeter is a device used for measuring electric current in a circuit, and voltmeter is a device used for potential difference between any 2 points in a circuit, or potential difference between 2 points in a conductor in a circuit. Right. Now we will take that ammeter. Right. Now an ammeter is a device used to measure current in a circuit, right? An ammeter is a device used to measure current in a circuit, and it is always connected in series with the circuit. Right. Now suppose we have a circuit, say a resistance R connected to a cell or a battery, right, with a plug key, battery and plug key. So when a current, right, I flows through the conductor, I, so it is a closed circuit, current is flowing through the conductor or resistance. If we need to measure the current, an ammeter has to be connected, right? The ammeter is connected in series with the circuit. This is an ammeter, this is positive terminal, this is negative terminal. This end-to-end connection is called as, right, series combination, or we can write that this is the ammeter and this is resistance, right? Now this ammeter measures a current, right? There is a scale and a pointer in the ammeter, right? Now as the pointer, right, moves, right, and it comes to rest, it indicates the value of current flowing through that resistor, right? And it measures the current in the circuit. It is because when electrical components are connected in series, the same current flows through each component of the circuit, right? Here, when we connect that ammeter in series, that is end to end, the same current which is flowing through the resistance, right, is flowing through the ammeter. Therefore, right, an ammeter is always connected in series with a circuit, and resistance of ammeter is very small, right? So resistance of the ammeter is very small, because if it has a larger resistance, as we know that V is equal to IR, if ammeter has larger resistance, right, it increases the resistance of the circuit, thereby decreasing the current. Therefore, an ammeter has very small resistance, so that it will not reduce the value of current in the circuit. So these 3 points are important regarding ammeter, a current measuring device. Now, another device, it is voltmeter. Now, a voltmeter is a device used to measure potential difference between any 2 points in a circuit, or potential difference between a conductor or resistance in a circuit. Right. Now, to measure potential difference between 2 ends of the conductor, a voltmeter is always connected in parallel. Right. A voltmeter is always connected in parallel with the points or component, right? For example, we have a circuit consisting of a resistance R connected to a battery with a plug key. Right. Now, when the circuit is closed, a current flows through the circuit. Right. Now, then arises the potential difference between the 2 points. Right. A and B are the 2 points in the circuit. Right. They represent the ends of the conductor. Right. Then this voltmeter has to be connected in parallel. Right. That means one end of voltmeter and one end of resistance are common. The other end of voltmeter and the other end of resistance are common. Now this is positive, this is negative, right? Just as in the case of ammeter, here also there is a scale and a pointer. The pointer indicates the potential difference between these 2 points, right? Now it can be represented like this. This is resistance R, point A, current I, point B. Now this is voltmeter, plus or minus. Now the third important point is a voltmeter has a very high resistance. A voltmeter has a very high value of resistance. Ammeter has very low value of resistance. But voltmeter has very high value of resistance. It is because when this current comes to the point A, it divides into 2 parts, right? One part of current flows through the voltmeter. As we know that V is equal to IR. As the current flows through voltmeter, right, a small amount of current, the current through resistance decreases, potential difference decreases. Therefore, right, the voltmeter should draw very small current from the circuit, so that it should not alter the value of potential difference, right? As we have I is proportional to 1 by R. If the R is very high, the current flowing through the voltmeter is very small, so that it does not alter potential difference between 2 ends of the conductor, right? So voltmeter has a high resistance because it can draw very small current from the circuit, so that it does not alter the value of potential difference between the ends of the conductor, right? Is that clear? Ammeter device used to measure current in a circuit. Voltmeter is a device used to measure potential difference between any 2 points in a circuit. How they are connected? An ammeter is always connected in series with the component or circuit, right? That means end-to-end connection. It is because the current flowing through the circuit, right, should flow through the ammeter. That means same current flows through circuit as well as ammeter, right? And the third one, right, here, that voltmeter is always connected in parallel because it has to measure potential difference between any 2 points, right? And regarding resistance, an ammeter has very low resistance and a voltmeter has a very high resistance, right? Now these are the measuring devices, right? The device used to measure current and the device used to measure voltmeter. Now we see that when we are having two resistors, right? So R1 and R2. If they are connected like this, end to end, R1 and R2. Just imagine an ammeter and resistance. These resistors are said to be connected in series. They are end to end connection. Suppose if they are connected like this, this is R1, this is R2. If they are connected like this, right, so that they have common points, right? That means the two resistors are connected between two common points. One ends are common and the other ends are common to the other point. This combination is called as parallel combination of resistors, right? You see, this is R, this is voltmeter in the circuit, right? The thing is, in series combination, the current remains the same. The current flowing through R1 is same as current flowing through R2. But potential difference across R1 is different from potential difference across R2. We will discuss it later. But in parallel combination, the current through R1 and R2 are different. Here the current is I1, here the current is I2. Then what is same? Potential difference between R1 and R2 are same. So in electric current, to remember that in series combination, right, of components, current remains same, potential difference is different. In parallel combination, potential difference remains same, but currents are different.